awak yang tu lah. Jangan lupa subscribe channel kita, tanda sokongan. Terima kasih. Assalamualaikum and hi everyone. So welcome back to channel Madam Fika Fiki. Jadi video kali ini kita akan teruskan lagi preparation for final exam semester 2 dengan soalan-soalan dari set 2. Okay, so apa tunggu lagi? Jom kita mula. Okay, so let's start with question number 1A. Okay, so look at the question. We have 3-point charges here. Okay, we have Q1, Q2, and Q3. Okay, so if I have this type of question, I like to label all the charges. Alright, so this is Q2 and this is Q3. Okay, so all the charges are arranged in a straight line. So the question states that the charge is in equilibrium. So calculate the distance x between this one, x between -3 microcoulomb charge and 5 microcoulomb charge. Alright, so please highlight the word charge in equilibrium. Okay, so when we talk about equilibrium, so please remember that the resultant electrostatic force on the second charge is equal to 0. So we can write the total force on charge 2 is equal to 0. Okay, so let's try to draw all the forces on the second charge. Alright, so since this is negative charge and this is positive and this is also positive, okay, means that the force on the second charge due to the third charge is to the right. Means that the second charge is negative, so it will be attracted to the third charge. So the direction of the force on second charge, Q2, should be to the right. So let's label F on 2 due to the third charge. Alright, and same goes to this one. Okay, Q2 will be attracted to Q1, therefore the direction is to the left, and it is equal to F on 2 due to 1. So please remember, if the direction of the force is to the right, means that the value is positive. If the direction is to the left, means that the value is negative. Okay, so now let's substitute. The total force on Q2 is equal to F23 to the right plus negative F21, and it's equal to 0. Okay, so let's highlight negative sign. So rearrange the equation so we can write F23 is equal to F21. Okay, so let's substitute the equation for the electrostatic force, okay, on charge 2 due to third charge. This is the electrostatic force on Q2 due to Q1. Okay, so it's equal to KQ2 Q3 over the distance between 2 and 3 squared, and it's equal to KQ2 Q1 over R21 squared. Okay, so you can look at here, we can cancel the value of K and also Q2. Jadi kalau dalam exam tiba-tiba soalan tak bagi nilai Q2, okay, soalannya sama macam ni. Okay, on the second charge, it is equilibrium, tapi Q2 is not given. Okay, jangan risau, substitute dulu. Okay, later you can cancel Q2. Alright, so we can write Q3. So now we can substitute all the values. So it's equal to 5 micro. So make sure in your calculation, tolong substitute ni. Nilai micro ni, micro, nano, pico. Okay, so over, so R23, so R23, okay, kat sini kita dah tahu dia adalah X. So substitute X squared is equal to Q1 is 8. Alright, 8 micro over, okay, so if here is X, okay, means that the remaining, okay, the remaining distance here should be 10 minus X. Okay, so dia akan jadi 10 minus X. Tengok betul-betul. Okay, Jangan hafal selalu minus je, kadang-kadang dia 10 plus X. Tengok kedudukan pada mana kita nak kira tu. Okay, so the next part, so this is mathematical part. Okay, you can look at here. We have squared here. Jangan expand. Please don't expand the equation. Jangan buka bracket tu. Bukan nak kata salah you expand the bracket, the equation. Okay, tapi nanti you boleh jadi mistake lah. You akan buat mistake dan salah kira. So, apa yang saya akan buat? So, saya akan kumpulkan yang ada squared ni in one side. Okay, so ini naik atas dan ini turun bawah. Okay, so dia akan jadi apa? Okay, so kita sambung lah. Dia akan jadi 10 minus x squared over x squared is equal to 8 micro over 5 micro. So, micro I can cancel here. And then, let's take square root for the both side. Okay. Okay. So, dia akan jadi, so cancel squared. Alright. So, 10 minus x over x now. And square root 8 minus, and square root 8 over 5. Okay. So, it's equal to 1.2649. Alright. Therefore, 10 minus x is equal to 1.2649x. Okay. And it's equal to, ini saya sambung kat sebelah ni, kosong kan. Okay, so 10, okay, equal to 1.2649x plus x, it's equal to 2.2649x. Okay, therefore, x is equal to 10 divide 2.2649. Okay, and finally, x is equal to 4.4 centimeter. Okay, so the question asks us to find what is the distance x. So the distance x is equal to 4.4 centimeter. Okay, alright, so let's proceed to question 1b. Okay, question 1b, we have 2-point charges, Q1 and Q2. Alright, so let's label. Q1 is positive 3 microcoulomb. Okay, so this is Q1. Okay, at the bottom, positive 3 microcoulomb, while Q2 is negative 5 microcoulomb. Okay, so the length of the side of the triangle is given. Okay, so given that P is the third corner of the triangle. So here we have P here. Okay, it's a point. And then we want to calculate the magnitude of the electric field at P. Okay, remember from the previous video, okay, pada set 1 saya ada discuss, okay, for electric field and electric force. So before you start your calculation, make sure you draw first. What is the direction of the electric field at point P? Ataupun electric force on charge Q1, Q2, Q3, it depends on the question. Okay, so now you must draw. Okay, must draw direction. Saya ulang lagi sekali, but in your calculation, please don't include the negative sign of the charge. Okay, for potential and potential energy, dia akan jadi terbalik lah. Please don't draw direction. Okay, because this is the scalar quantity, but in your calculation, make sure you include negative sign of the charge. Okay, dua benda yang berbeza. And this time, we want to calculate the electric field at point P. So, field mesti draw direction on point P. So, let's start. Okay, so on P, okay, we consider this is as positive. So, look at here, we have positive and this is negative. Means that the direction of the electric field at point P due to Q2 should be in this direction. P attracted to Q2. Kita consider macam tu. Okay, so direction dia, okay, awak kena macam ini. So, dia akan tulis E2. Okay, and how about E1? Okay, so look at here, positive and this is also positive. So, means that this point will be repelled to the right. Okay, so positive dia akan repel lah. So this direction. Okay, so E1. Okay, so please label macam tu. Okay, then you can start your calculation. So before we resolve E2, okay, since E2, the direction of E2 at some angle of theta here, so let's calculate what is the angle of theta. Okay, so kita boleh kira lah ni. So dah akan jadi sin theta, let's say I use sin, is equal to 0.4 over 0.5. Therefore, theta is equal to 53.13 degree. Okay? Alright. So now this is 53. Okay, saya letak sini terus. 53.13 degree. Okay? So the next step, I want to calculate what is the value of E1 and E2. Okay? So we can calculate where E1 is equal to KQ1 over R1 squared. Okay? So masukkan nilai dia lah. Okay, K is 9 exponent 9 times 3. Okay, exponent 6 for Q1. And then the distance R1 is the distance from point P to Q1 is 0.3 meter. Masukkan semua nilai tu. Okay. So dah akan jadi berapa? Tekan calculator. Practice tekan calculator. Okay, bukan dalam exam je baru nak tekan. Okay, so 3 exponent 5 Newton per coulomb. Okay, and same goes to E2. Kira dulu E2, jangan resolve lagi. Okay, so substitute all the values. Okay, and Q2 ada negatif kan? Jangan masukkan negatif. So it should be 5 exponent negative 6. Okay, jangan masukkan nilai negatif ni. No need, because this is electric field. Okay, so the distance between P and Q2 is 0.5. Alright, so let's substitute 0.5 squared. Okay, and it's equal to 1.8 exponent 5 Newton per coulomb. Okay, so now we finish calculate E1 and E2. So remember, we need to resolve. Okay, want to get a green color. So we need to resolve E2 into E2y and E2x. Macam tu. Okay, so kita kalau nak buat table pun boleh. Let's say awak kata suka buat table. Okay, so x component and y component. Okay, so dia macam ni lah. Kita buat macam tu. So kita ada E1 and E2. Where E1, okay, the direction of E1 is to the right only in x component. Tak perlu pun resolve. So E1x is E1x lah. Okay, so 3 exponent 5 kita dah kira tadi. Okay, this one should be 0. Tapi E2 kita kena resolve. So E2x dia akan jadi, okay, since look at here, the direction of E2x is to the left, means that E2x should be negative value. So dia akan jadi negative E2 cos theta. Okay, so substitute all the value. E2 tadi kita dah kira dekat sini. Alright, masukkanlah E2 cos theta is 53.13. Okay, so E2x would be equal to negative. Okay, don't forget to put negative 1.08 exponent 5. Alright, how about E2y? So E2y is upward, so positive value. So it should be E2 sin theta. Please substitute all the values. Okay, E2 and theta, the angle. Therefore, E2y should be equal to 1.44 exponent 5. Okay, so what is the next step? We need to total up. Okay, E21 x and E2x, the total electric field in x component. Okay, tambahkan semua yang ada tadi. Okay, E21x, okay, remember E21x tambah E2x. Okay, E2x ni negatif, so you akan dapat nilai dia 1.92 exponent 5. Okay, Okay, and total electric field in Y component. Okay, samalah, kita tulis saja balik. Okay, so the question asks us to find the magnitude of the electric field at P. Dia sebut magnitude, jadi tak perlu bagi direction pun, tak apa, tak hilang markah. Okay, therefore, let's write, okay, the magnitude of the electric field at point P is equal to total electric field in X component squared plus total electric field in Y component squared. Okay, so nilai yang ini, sekejap saya highlight. Jadi nilai yang ini dan yang ini, kita substitute dalam ni lah. Okay, so you akan dapat the magnitude of electric field at point P is equal to 2.4 exponent 5 Newton per coulomb. Okay, so this is the answer. Okay, so dia sebut magnitude of the electric field. In case soalan bagi tahu calculate the electric field ataupun calculate the resultant electric field at P, okay, dia tak sebut perkataan magnitude, make sure you tinggalkan jawapan you sekali dengan direction. Okay, so means that the direction theta inverse tangent total electric field Y over total electric field X. Okay, you substitute, okay, this value tadi. Okay, kita masukkan. So, you akan dapat angle dia equal to 36.87 degree. Okay, kalau kita lukis, awak tengok kat sini total EX dia dapat mana? Tadi dapat positif kan? Okay, dua-dua dapat positif. So, maknanya total EX in this direction. Y pun positif, so means upward. Okay, so inilah kita punya resultant E tadi. Okay, and the theta here yang kita kira tadi 36.87 degree. Okay, means that 36.87 degree, the direction is above positive x-axis. Okay, so ini positive x-axis. So ini positive x-axis. Kalau disambung sini, ini negatif, sini negatif x-axis. Okay, so dia above positive x-axis. Okay, so question B2, calculate the electric potential. Electric potential. Okay, so remember electric potential, this one V, no need to draw direction at point P. Terus saja kira. Guna formula, but in your calculation, you must include negative sign for the charge. Okay, so B2, we want to calculate potential at P. So, it's due to charge 1 plus due to charge 2. V1 plus V1 plus V2. Okay, so equation for V is KQ over R. Okay, tengok betul-betul tak ada square-square. KQ1 over R1 plus KQ2 over R2. Okay, so make sure your R2 is negative sign, right? So, when you substitute in your calculation, okay, look at here. So, Q1, okay, saya factorizekan dulu K tu. 3 times 10 power of negative 6 over, the distance is 0.3. Okay, look at here, plus negative 5 microcoulomb. So, this is negative. Okay, so 0.5. Okay, so let's try to calculate final answer. Okay, VP, the potential at point P is equal to 0. Bila kita kira, kita dapat 0. Okay, and the last one, the third, B3. Okay, the work needed to bring a test charge from infinity to point P. Okay, let's say this is the point P just now. Okay, so let's say we have a test charge, Q0. So we want to bring this test charge, which is the distance of the test charge is from infinity. Okay, so initial position of the test charge, I will put R1, which is equal to infinity. Lepas tu, we want to bring to point P. Okay, so what is the work needed to bring a test charge from infinity to point P? Okay, means that W is equal to the test charge that we want to bring. Okay, yang ni dia tak bagi tahu berapa kan. Kalau dia bagi tahu berapa, kena substitute dalam equation. Tapi kat sini dia ada trik. Sebab tadi VP dia kosong, awak tengok ya. So W is equal to Q0 times delta V, where delta V is the potential difference. Okay, so bila kita masukkan, dia akan jadi Q0. Okay, kalau awak dah tahu, dia sebenarnya V final minus V initial. Okay, so V initial, potential of V initial is 0 lah. Sebab, tengok ya, KQ over R. Kan? So, R is infinity. So, ini akan jadi 0 lah. And ini final position kita adalah VP. So, kalau kita tulis Q0, VP minus V at infinity. Okay, so potential at infinity, remember, okay, it's equal to 0. So, kalau sini dah 0, VP kita kira tadi 0. Therefore, W is equal to 0 joule. Okay, so, finish question B3. Okay, so let's proceed to question C, 1C. Okay, for question 1C, alright, look at the question. So we have an electron. Okay, this is an electron. Okay, so for question C, so we have an electron here. So this is an electron enters a region of uniform electric field. Okay, remember when we have two plates here, so the electric field between the plates is uniform electric field. So if the magnitude of the electric field is 200 Newton per Coulomb, so given that E is equal to 200 Newton per Coulomb, so calculate the acceleration of the electron. So we want to calculate what is the acceleration of this electron when it enters the electric field. Okay, so if we draw the free body diagram on the electron, so actually, let's say here, oh sorry, so I want to change the color. So let's say this is negative. So always remember that negative charge would be attracted to the positive plate. Okay, so that's why you can see here the path, okay, the motion of the electron after enters the electric field, okay, and it will moving in downward direction. Okay, that akan deflected downward. So now if we draw all the forces on the electron, so since this is electron, negative charge, that means there is an electric force, okay, on the electron, which is the direction is downward. Kenapa dia downward bukan upward? Kan saya kata tadi, sebab dia negative charge electron, dia akan attracted to positive plate. Okay, and remember, there is also a weight of the electron. Okay, so setengah buku awak akan nampak dia akan tambah weight. Okay, sekarang saya akan buat dua-dua cara lah. Okay, tambah weight, kita consider the weight of the electron dengan yang tak consider the weight of electron. Jawapan dia nanti, acceleration, you akan dapat jawapan yang sama. Kenapa? Sebab the weight of the electron is very, very small. So, dia tak effect sangat. Okay, tapi yang paling tepat dalam free body diagram kita mesti ada weight of the electron. So now, let's try to calculate what is the acceleration of the electron. So, total force is equal to MA. So, on the electron, we have two forces. Fe downward, W also downward. Okay, so kedua-duanya positif lah. Kenapa? Sebab direction dia bergerak ke bawah kan? Okay, same direction. So, dia akan jadi Fe plus the weight of the electron equal to MA. So, QE, Fe is equal to QE plus mg is equal to ma. Alright, therefore, the acceleration of the electron should be equal to QE plus mg over m. Okay, so let's substitute all the values here. Q is the charge of the electron. Okay, E is the electric field, dia dah bagi tadi. And this is the mass of electron. Okay, G is 9.81 and M here is the mass of electron. Check dekat depan, list of constant tu ada. So finally, after you substitute all the values, okay, saya pasti you akan dapat jawapan 3.51 exponent 13 meter per second squared. Okay. So ini jawapan yang saya dapat jika saya consider the weight of the electron dalam saya punya free body diagram. Okay, so sekarang what if we try another method? okay, by using the equation of A. Okay, we strictly ignore the wake. So F is equal to MA. So the only force that we consider is the electrostatic force on the electron. And yeah, so QE equal to MA. Alright, therefore A is equal to QE over M. So when we substitute, alright, Q is the charge of electron. Okay, 1.6 exponent negative 19. Okay, E is 200, where the mass of the electron is 9.11 exponent negative 31. Okay, so A dia awak tekan calculator, exactly equal to 3.51 exponent 13 meter per second squared. Okay, alright. So kalau tanya saya prefer you consider the weight. Okay, sebab kita tak boleh lah ignore weight of the electron kan. Walaupun kita kata weight of the electron sangat kecil. Okay, tapi kalau kita masukkan dalam kita punya calculation, kita still dapat jawapan yang betul. Dan dalam masa yang sama, kita punya equation kita lebih tepat. Okay, so finish question number 1. So let's proceed to question number 2. Okay, question number 2A. So look at here, we have a parallel plate capacitor that filled with air has plates of cross-sectional area. So the area is given in centimeter squared. Okay, remember, ini macam perangkap awak lah kan, 250 centimeter squared. Okay, so make sure you change centimeter squared to meter squared. Okay, kalau rasa tak nak careless, okay, tulis balik. 250 cm squared. Okay, saya akan buat darab silang. So centimeter, meter. So remember, 1 meter equal to 100 cm. But this time we have squared, right? This one. So semua ini kena squared. Squared kan macam tu. So bahagikanlah 250 divide 100 squared. So the area in, ni boleh cancel the unit. So the area in meter squared is equal to 250 times 10 power of negative 4 meter squared. Okay, soalan ni senang. Tapi mungkin kalau salah unit, dia akan jadi salah lah. Same goes to D. Okay, so diameter is given in millimeter. So 2.0 exponent negative 3 millimeter. Okay, negative 3 meter. Okay. And this capacitor is connected to a battery. So where V is equal to 150 volt. Okay, that's mean we have capacitor and then we have a battery. Okay, so V and C. So the question asks us to find what is the capacitance of the capacitor. Okay, where C is equal to epsilon naught A over D. Okay, so ni masuk saja dalam formula. Tapi make sure you tukarkan ke semua unit tadi dengan betul. So we have A and D. Okay, so epsilon naught is given. So just substitute all the values. Therefore, the answer is equal to 1.11 times 10 power of negative 10 farad. Okay, masukkan semua nilai itu. Okay, so this is the answer. And then the second part, which is A2, the question asks us to find what is the charge on each plate. So this is very simple, where Q is equal to CV. So we have 1.11 exponent negative 10 farad. So when the capacitor is connected to the battery of 150 volt, so 150 volt, therefore, okay, the charge in the capacitor should be equal to 1.66 times 10 power of negative 8 C, which is coulomb. Unit jangan lupa. Sayang unit lupa, hilang markah. Okay, alright. So how about 2B? Okay, let's proceed. Okay, for 2B, this time the battery is then disconnected. Okay, remember, let's say this is the before ataupun initial condition. Okay, and what happened? Okay, after, so we disconnected the battery from the capacitor, and then, okay, this is the capacitor C, And remember that we have calculated the charge collected in the capacitor, where the charge Q is equal to 1.66 times 10 power of -8 coulomb. So when the capacitor is disconnected from the battery, please remember, okay, all right, so I will put here, okay, please remember that the charge, okay, the charge in the capacitor should be constant. Constant tu maknanya kalau tadi masa dia dengan bateri dia dah fully charged 1.66 tadi, okay, so when disconnected from the battery, so the final condition, the charge still equal to 1.66 exponent -8 coulomb. Okay, so now look at the question. Soalan kata apa lagi? How does the potential difference in a capacitor change, okay, when the dielectric sheet is inserted? Okay, so we have dielectric material here. Okay, so dielectric, okay, sheets is inserted. Okay, so if you watch the previous video, which is set 1, I have wrote about the relationship between the initial capacitance and the final capacitance after we insert the dielectric material. Okay, so always remember all the relationship between C and C0, V and V0, E and E0. Okay, so in this case, we will write C is equal to epsilon R, which is the permittivity of the dielectric, and times C0. Okay, C0 ni adalah capacitance of the capacitor without dielectric material. Dia ada air saja. Okay, and C is the final bila kita dah insert dielectric material. So what happened when we try to insert the dielectric material between the plates? Okay, you can see here the capacitance of the capacitor should be increased. Okay, bila kita masuk dielectric material, the capacitance of the capacitor should be increased. So if you want to answer the question, okay, what is the change of the potential difference? Ada perubahan tak bila kita masuk dielectric sheets tadi? Okay, so kita boleh tulis, okay, kita relatekan Q is equal to CV. Remember, Q is equal to CV and V is equal to Q over C. Okay, so when we insert the dielectric material, automatically C is increased where Q is constant. Okay, remember Q is constant. And what happened to the potential difference in a capacitor? So the potential difference in the capacitor should be decreased. Okay, so awak tulislah. Okay, V will be decreased. Boleh? Alright. Okay, so finish question number 2. Let's proceed to question number 3. Okay, question 3A. Calculate the resistance of a 5 meter long aluminium wire with a diameter of 1 millimeter. So given that the resistivity of aluminium at temperature of 20 degrees Celsius is 2.8 exponent -8 ohm meter. Betulkan unit dia tu ohm meter sebenarnya tu. Sama dengan degree Celsius tu. Okay, so let's take out all the informations given. So we have L is equal to 5 meter. Okay, and then we have D. Okay, so D is equal to 1 millimeter. And okay, diameter, so means that we need radius in order to calculate the area. Okay, the cross-sectional area of the wire. So it's given to 0.5 exponent -3 meter. Okay, then we can straightly calculate the area. Because we want to use equation rho is equal to RA over L. That's why we need area. Okay, the cross-sectional area is pi r squared. So substitute the value. Jangan masuk diameter, masuk radius. Squared jangan lupa. Ni ramai yang tertinggal bila kira area. pi r. Okay, salah. Pi r squared. Okay, so the area is equal to 7.854 exponent negative 7 meter squared. Okay, and given that the resistivity is equal to 2.8, okay, 2.8 exponent negative 8 ohm meter. Okay, alright, so what's the question? Okay, calculate the resistance. Okay, so this is very simple. We just rearrange this equation, and then R is equal to rho L over A. Okay, so substitute resistivity. Okay, the length is 5 meter and the area here, so it will give you the answer of 0.18 ohm. Okay, yes, very simple. Okay, make sure kalau salah pun mesti pasal unit lah bila you convert tu. Okay, you tak check betul-betul, so jadi salah. Okay. Okay, question B. Okay, so let's proceed to question B. Okay, look at this question. Okay, this time we have 3 resistors. Okay, where it's connected to a battery of 15 volt. Okay, so I want to label all the resistors. Okay, untuk jawab soalan ni saya lebih suka label supaya senang nanti saya nak tengok mana satu yang parallel, mana satu yang series. Okay, so this one should be R1 and I want to label this as R2 and this one is R3. Okay, alright, so yeah, determine the effective resistance or the total resistance of the circuit and then calculate the current that flows through the 4 ohm resistor. So in this case, 4 ohm resistor is referring to the third resistor here. Okay, so now look at the flow of current. Okay, so if you look at here, you can see that the flow of current, okay, from here I, okay, and when the current reach the junction, so what happened? It will split into 2 values of current. Okay, so let's say saya namakan dia I1, I2. Contohnya kan, ini nak tunjukkan dekat awak di mana the amount of current that flow through R3 and R2, okay, is a different amount of current. Okay, so I1 dengan I2 ni tak sama. So that's mean R3 and R2 are parallel. Okay, so ini adalah sebab bila kita ada junction je, okay, saya dah pesan ya banyak kali. So bila you nampak junction, okay, so I is split into I1 and I2. So ini dia akan jadi parallel. Okay, maknanya current yang lalu dekat R3 dengan R2 tu tak sama. Darah yang mengalir tu tak sama. Macam tu. Okay, kau nak ingat. Okay, jadinya R3 dengan R2 tu family lain-lain. So they are parallel. Okay, so let's write 1 over R23. We want to combine R2 and R3 and we want to find what is R23. So since they are parallel, so 1 over R23 is equal to 1 over R2 plus 1 over R3. Okay, so let's substitute. So remember, this is R1 over R23, bukan R23. So bila you dah tambahkan 1 over 6 plus 1 over 4 ni nanti, so terbalikkanlah. Therefore, okay, R23 is equal to 2.4 ohm. Jangan buat mistik-mistik kecil macam ini. Nanti dia tambahkan 1 over 6 plus 1 over 4. Dia kata itu adalah nilai R23. Sebenarnya itu adalah nilai 1 over R23. Kira betul-betul. Okay. So sekarang, let's combine. Okay. So R23. So I want to draw the new circuit. So this is the EMF. Okay. So this is R1 and this is R23. So R23 we have 2.4 ohm and R1 is 5 ohm. Okay. So R23, so they are parallel. Okay. But this time we have R1 and R23 and they are in series. Okay. So series. Okay, so let's calculate. R total dia akan jadi equal to R1 plus R23. Therefore, 5 plus 2.4 and the equivalent resistance ataupun effective resistance is 7.4 ohm. Okay, so this is the answer. Alright, so second, we want to calculate the current that flows through the 4 ohm resistor. So this is very interesting question. Okay, so how to answer this question? Okay, so now when we have R total, so dekat here we have the flow of current I. So I will put this as I total. Okay, sebab dia dah circuit last sekali kan. Okay, so kita nak cari I. Kita tahu sini tadi R total here. Okay, so this is combination between R1 and R23. And they are in series. Okay, so let's put another color. So they are in series. Okay, so now when they are in series, means that the current I total will equal to current that pass through R1, and it also equal to current that pass through I23. Okay, so kita kena kira dululah I total kita. So let's calculate the I total. Okay, so V total is equal to I total R total. Okay, so sekarang kita nak kira I total is equal to V total is given 15 volt. Okay, so this is 15 volt over R total yang kita dah kira 7.4. And finally, I is 2.03 ampere. Okay, di mana this value is also the same value of current that pass through that pass through R1 and pass through R23, which is 2.03 ampere. Okay, so look at here R23. So when we calculate R23, so I can calculate V23. So kita nak pergi dekat resistor yang ketiga tadi. Okay, so kalau saya kira V23, okay, saya letak R23 sebab saya nak kira V23. Okay, so saya nak kira V23 and it's equal to I23 R23. Okay, V23 is equal to I23 R23. Okay, R23 dah kira kan tadi. Okay, which is equal to 2.4 and I23 pun dah dapat dah tadi. Therefore, V23 kita, okay, 2.03 R23 is equal to 2.4. Okay, and it's equal to 4.872 volt. Alright, and please remember that R23 ataupun V23, okay, this one, this is the combination, okay, R23 is the combination of R2 and R3 and they are parallel. Okay, they are parallel. Sebab tu you kena tahu siapa yang series, siapa yang parallel. So R2 and R3, they are parallel means that V23 yang kita dah kira, okay, boleh parallel apa yang sama? Voltage yang sama. Kalau series, apa yang sama antara resistor tu? Current yang sama. Okay, so V23 equal to V2 is equal to V3 and it's equal to 4.872 volt. Kenapa saya sibuk-sibuk nak cari V2, V3 ni? Okay, sebab saya nak kira current that pass through 4 ohm resistor. Di mana 4 ohm resistor kita ni adalah R3. Dekat sini. Okay, so saya nak dapatkan nilai ini. Okay, last kali saya bolehlah jawab. Okay, so V3 is equal to I3 R3. Therefore, saya nak cari I3 ni. Okay, current that pass through R3 is I3. So, V3 over R3. Where V3 is equal to, dah tahu dah tadi V3 ni. Okay, 4.872. 4.872 and R3 is 4 ohm. Okay, and the answer is equal to, cuba kira berapa dapat tu. Okay, so the answer is equal to 1.22 ampere. Okay, unit jangan tinggal. Nanti penat-penat kira, ke akhir hilang 1 markah. Okay, so finish question B. So let's move to question C. Okay, question C. Here we have 2 loops. Alright, so we have combination of 4 resistors and 2 EMF. Okay, kita ada 2 battery dekat sini. Okay, so we can relate with Kirchhoff law. Okay, so so let's label the flow of current. Okay, so soalan ni dia tak beri the flow of current, so kita kena lukis sendirilah. Okay, as we know that current from the battery should be flow from the positive terminal, right? So I will write this as I1. Okay, so this should be I1. So for the second loop, since second loop has 1 battery only and first loop also has 1 battery, so as we know that current that flow from the battery is from the positive terminal, so means that this should be, I will label this as I2. Okay, so this is I1, and when they reach the junction, okay, so they will combine and produce I3. Okay, kita tentukan sendiri. Okay, so sampai kat junction ni, nanti ini dia akan kembali kepada I1, so ini dia akan kembali kepada I2. Okay, and then let's draw our loop. Okay, so for the first loop, I will follow the flow of current, okay, which is clockwise direction. Okay, and this one is anti-clockwise direction. Okay, loop ni tak kisah sebenarnya. Okay, so calculate the current flowing through 5 ohm resistor and 4 ohm resistor. Okay, so 5 ohm resistor, the current that pass through 5 ohm resistor is I1. So kita nak cari I1, and the current that pass through 4 ohm resistor is I2. Okay, so nak tak nak kita kena guna Kirchhoff rules. Okay, so we have 2 rules. Okay, let's write the first one. Okay, where total current in is equal to total current out. Okay, total current in, total current out ni apa benda dia? Okay, so tengok pada junction ini. Current that flow into the junction is I1 and I2. And current that flow out from the junction is I3. Okay, so kita letak siapa yang into the junction? I1 and I2. Siapa yang keluar? I3. Okay, so saya akan rearrange this equation. Okay, letak yang ada I dekat one side only. So dia akan jadi I1 plus I2 minus I3 is equal to 0. Okay, so this is my first equation. Okay, and next, okay, let's look at the second rule. Okay, where total, okay, I will write total EMF is equal to total IR. Okay, total EMF is equal to total IR, and I will divide into, so I will divide into loop 1 and loop 2. Okay, so now look at loop 1. Total EMF is equal to total IR. So total EMF for this loop, we just have 1 EMF. Okay, and remember, okay, this small arrow, tengok, comparekan arrow yang kita lukis tadi. Remember, kalau saya dapat soalan Kirchhoff, saya akan lukis small arrow, okay, dekat atas positif tu. Maknanya kita tahu current daripada battery mesti flow through the positive terminal, right? So if the small arrow yang kita lukis atas ini same direction with the loop, so means that the value of the EMF here should be positive. So total EMF for the first loop ada satu saja EMF, so 12. Okay, dia bukan negative 12. Equal to totalkan resistance darab dengan current. So we have R2 here, where the current that pass through R2 is I1. Okay, so current that pass through R3 is I3, and current that pass through R1 is I1. Okay, and look at the flow of current. Okay, I1 is the same direction with the loop, so it's positive value, positive I1 R2. And for this one, still same direction, so positive I3 R3. And the last one is positive as well, since the direction of I1 is the same direction with the loop. And it is I1, positive I1 R1. Okay, so let's write, okay, 2 I1 plus 6 I3 plus 5I1. So I1 ada 2 tu. Okay, kita tambahkan je terus. 7I1 plus 6I3. So this is my second equation. Okay. And how about loop 2? Okay, look at here for loop 2. Okay, still we can see here that the direction of this small arrow yang saya lukis tu the same direction as the loop. Okay, yang saya lukis. So 14 volt is positive value. So 14, So 14, okay, buat macam ni. Equal to, okay, so this is also positive, same direction, I2, R4, I3, R3. Okay, so in second loop, we just have 2 resistors here. Okay, so it should be 4I2 plus 6I3. Tengok betul-betul siapa yang lalu dekat dia, I3. Jangan salah letak nanti salah kira lah jadinya kan. Bukan tak faham, bukan tak tahu buat, tapi careless. Okay, so this is my third equation. Okay, so after we finish write all the equations, pastikan betul lah ketiga-tiga ni. Okay, baru dapat markah. Okay, so kita akan substitute dalam calculator. Tak perlu nak buat simultaneous equation. Okay, just use your calculator and substitute value of A, B, C and D. Okay, so contoh kita ada, okay, I1, saya buat table sekejap. Okay, so saya ada I1, I2, I3 and equal to berapa. Okay, macam tu. Baik, tak muat. Okay, tambah sikit lagi. Okay, macam tu lah. So, equation number 1, kita tengoklah equation number 1 kita. I1 is 1, I2 is 1, I3 is negative 1, and equal to 0. So, kita letak 1, 1, negative 1, 0. Okay, second equation, I1 is 7, I2 ada tak? Tak ada. So, I2 is 0, I3 is 6, okay, equal to 12. So, I1 is 7, okay, I2 is 0, tak ada. I3 is 6 and equal to 12. Same goes to the second loop. Okay, I1 tak ada. I2 is 4. I3 is 6 and equal to 14. Okay, so tekan calculator, ambil equation. Okay, yang ada 3 equation tu A, B, C, D. And after you press equal. Okay, so you akan dapat nilai. Dia akan keluarkan bacaan X is equal to 0.38. Y is equal to 1.17 and Z is equal to 1.55. Okay, so means that this is the value of I1, okay, I2. So kita dah susun I1, I2, I3 tadi kan. So kita ikutlah jawapan tu mesti ikut dia punya kedudukan dia. So I3. Okay, so sekarang kita nak jawab soalan the current that pass through 5 ohm resistor. Okay, so 5 ohm resistor adalah R1. Okay, and then 4 ohm resistor adalah I2. Okay, so current that pass through R1, which is 5 ohm resistor. Okay, so it is I1 and it is equal to 0.38 ampere. Okay, so current that pass through 4 ohm resistor, okay, which is R4 tadi, 4 ohm resistor, which is I2 and it's equal to 1.17 ampere. Okay, so kita dah dapat jawapan. Okay, so finish question 3C. Okay, kita akan proceed to question 3D. Okay, so let's read the question first. So figure 6 shows 2 cells. So we have EMF A and EMF B here. And a galvanometer G, which is connected to slide wire OX. Okay, by a jockey Y. So this is the jockey. The length of the slide wire, so slide wire means that OX. So the length of the slide wire is given 1 meter. Okay, and given that the resistance of the slide wire, okay, dia dah kata dah the length of the slide wire is 1 meter and its resistance is 40 ohm. So saya tulis dulu siap-siap, ROX is 40 ohm. Okay, alright, next. When the distance of OY, so when you get here the jockey at Y, when the distance of OY is 40 centimeter, means that the galvanometer achieve equilibrium. So equilibrium means that no current flow through the galvanometer. Bila equilibrium saja means that the voltage across OY, VOY dia akan sama dengan EMFB. So saya tulis siap-siap. When IG is equal to 0, VOY is equal to EMFB. So ini yang you kena ingat konsep dia kat sini. Okay. So lagi apa lagi dia kata? Okay. If the EMF of B cells is 2.0 volt, oh dia dah bagi dah. So EMFB is equal to 2.0 volt. Okay. So ignore the internal resistance of each cell. Maknanya tak ada internal resistance of each cell. So we want to calculate the current which is produced by cell A. So we want to calculate what is the current I here. Okay, yang pass through this circuit. Okay, current that produced by EMF A. Okay, and then calculate EMF A tu berapa. Ini tak tahu nilai ni berapa. Okay, so kita nak kira. Okay, so kita gunakan konsep when IG is equal to 0, okay, the voltage across OY is equal to EMFB. So EMFB dia dah bagi kat situ. Okay, so let's write the general equation for VOY. VOY is equal to, V is equal to IR. Okay, so VOY is equal to I times the resistance from O to Y. Okay, so current I ni current yang lalu kat sini tadi. Samalah untuk circuit atas. So ROY. So you want to find what is current I. Okay, current that produced by the battery ataupun by EMF A, I. Dia adalah current yang samalah yang lalu dekat OY, yang lalu dekat YX dan juga yang lalu dekat internal resistance 5 ohm ini. Okay, so I is equal to VOY over ROY. Okay, so sekarang kita nak jawab soalan ni, nilai VOY kita tahu. 2.0 volt. Soalan dah bagi ni tadi. Okay, but now we have problem in order to calculate what is the resistance from O to Y only. Okay, so remember, soalan ada bagi dekat sini. Resistance from OX is 40 ohm. So kita boleh kira lah what is the resistance from OY. Kita guna ratio. Contoh, kalau wire tu 1 meter, the resistance tadi 40 ohm kan? Daripada O to X 1 meter and the resistance is 40 ohm, sorry. Okay. And kalau OY tadi 40 cm, 1 meter tu saya letak 100. Okay, 100 cm. Okay, so kalau OY tadi 40 cm, berapa pula dia punya ni? Kan? Berapa dia pula dia punya ROY? X tadilah ROY. Kita letak sini ROY. Okay, so kita boleh guna ratio lah. Okay, di mana length OX over length OY kita bagikan. Okay, equation ni dengan ini kita bagikan equal to 40 ohm ataupun ROX. Letak je lah 40. Kan? Kan bagikan 40 bagi ROY. So sekarang kita nak cari ROY. Di mana ROY is equal to 40, okay, 40 times L naught Y over L OX. Okay, ini. Boleh? So, dapatlah kira ROY equal to 40 times LOY tadi, 40 over LOX, 100. Okay, so dapatlah ROY is equal to 16 ohm. Okay, so dapatlah jawab soalan yang pertama. Therefore, okay, I is equal to VOY is 2 volt over ROY is 16. So the answer is 0.125 ampere. Okay, so ini jawapannya. Dan dia tanya pula calculate the EMF of cell A. Okay, yang tu saya nak jawab dekat tepi ni lah. Kan? Saya nak buat sini. Okay, saya nak buat kat tepi ni. Okay. So, D2 D2, question D2. Kita nak cari EMF A. So, kita boleh tanya lah V is equal to IR. So, EMF A is equal to I. Okay, I inilah kita dah kira tadi. I yang lalu ni, I yang sama. 0.125 ampere tadi. Darab dengan R total. Darab dengan R total. Bukan sekadar darab dengan 5 ohm sahaja. R total. Maknanya R total tu refer kepada ni lah. Okay, from O to X tadi ada resistance. Dia dah kata dah. Wire O to X ada resistance of 40 ohm pluskan dengan external resistor here 5 ohm. So kita nak dapatkan, okay, circuit atas tu kita nak dapatkan total resistance dia berapa. Okay, so dia akan dapat berapa tadi? I 0.125, total resistance adalah 40 ohm adalah resistance keseluruhan wire from O to X plus 5 ohm. Okay, so akan dapat jawapan 5.63 volt. Okay, itu adalah nilai EMF A. Okay, nanti ada yang tanya saya kan, Madam, kenapa Madam current tu lalu dekat atas je? Kan, kenapa dia lalu dekat atas je? Okay, remember when the reading of galvanometer is equal to 0, the flow of current daripada bateri A, okay, turun ke bawah sini, dan because of the potential difference VOY sama dengan potential difference epsilon B ni tadi, okay, EMF B. So bila potential difference VOY sama dengan EB kat bawah ni, so current, okay, current only flow from higher potential difference to lower potential difference only. So once VOY is equal to EMF B, so current cannot flow. Okay, dia tak boleh lalu daripada O ni, dia tak boleh turun ke bawah sini. Okay, daripada joki ni pun tak ada, daripada EMF ni pun tak boleh, tak ada current yang lalu. So bawah ni seolah-olah tak ada current yang lalu. That's why in order to calculate EMF A, kita consider current atas sajalah. Okay, dan circuit atas saja. And the total resistance for the upper circuit here is equal to ROX 40 ohm tadi pluskan dengan 5 ohm. Okay, so finish question number 3. Panjang soalan ni. So let's proceed to question number 4. Okay, so let's solve for question number 4A. Okay, so a 400 turns coil is rotating at 3000 revolution per minute. RPM is stand for revolution per minute. In a uniform 0.75 Tesla magnetic field. Okay, so the cross-sectional area of the coil is given 5 cm squared. So let's calculate the maximum induced EMF. So when we talk about rotating coil, okay, so the equation of the induced EMF is actually equal to NBA omega sin theta. Okay, so this is the equation. Okay, so given that the number of turns is equal to 400 and it's rotating at 3000 revolution per minute. So it's actually the angular velocity omega is equal to 3000 revolution per minute. Okay, buat satu-satu. So we need to change the unit revolution per minute into radian per second. Okay, so times. So look at here. So revolution at the top of the fraction. So we need another one in order to cancel the unit, right? Okay, so revolution ke atas, satu lagi revolution ke bawah. Okay, so kita nak tukar revolution kepada radian. One revolution is equal to 2 pi radian. So we can cancel revolution and then minute. Another one should be at the top of the fraction. Okay, so we want to change to seconds. Okay, so 1 minute is equal to 60 seconds. So cancel minute. Okay, so take your calculator. Okay, and then omega will equal to 314.16 radian per second. Okay, so ini belum jawapan lagi lah. Okay, so area, look at here. We have area in centimeter squared. Make sure you change to meter squared. Okay, so please change to meter squared so that area is equal to 5 exponent negative 4 meter squared. Kalau tak tahu tukar unit, okay, belajar macam mana nak tukar unit tu. Okay, ingat balik macam mana. Saya dah ajar dah sebelum ni. Okay, kat video sebelum ni pun dah ada. Okay, so now we want to calculate the maximum induced EMF. So maximum induced EMF, so sin theta, so it's equal to 1. So sin 90 is equal to 1 because we want to find the maximum induced EMF. So it's equal to NBA omega. So let's substitute all the equations. So given that the magnetic field, the uniform magnetic field is 0.75 Tesla. Tadi kita lupa nak keluarkan 0.75 Tesla. Okay, so area is 5 exponent negative 4. Okay, and last one is omega. Make sure in radian per second, 314.16 radian per second. Tak payah masuk unit. Okay, padam balik. Okay, so last kali you akan dapat 47.12 volt. Okay, so this is the answer. Okay, good. Okay, so now we continue with 4B. Okay, so question 4B. So figure 7 shows a round loop with diameter of 6 cm is in a uniform magnetic field. B is equal to 0.18 Tesla. So the magnetic field is perpendicular to the plane of the loop. The loop is then pulled out quickly from the magnetic field in 0.2 seconds. Okay, calculate the EMF induced in the coil. Alright, so for B, so let's write all the informations given. So we have diameter in centimeter. Okay, that means the radius is 3 centimeter. Please make sure you change to meter. Okay, and then we need to calculate the area, where area is pi r squared. Okay, so pi r is in meter. Okay, so the area is equal to 2.827 exponent negative 3 meter squared. Okay, and then apa lagi tu? Okay, magnetic field B is given 0.18 Tesla. So that means this is the initial one. So what happened when the loop is pulled out quickly from the magnetic field? Means that B final we consider as 0 Tesla, and the time, okay, dt is equal to, the change of time is 0.2 seconds. Okay, so we want to calculate the induced EMF. Okay, so this is very simple. So the equation is negative and A. So based on the Faraday's law, when there is a change of the magnetic field, so akan wujudnya induced EMF. So dia akan equal to dB over dt. Okay, so inilah equation dia. Okay, so it's equal to negative. So the number of loop is 1. So A is equal to 2.827 exponent negative 3, and B final minus B initial 0 minus 0.18, and dt is 0.2 seconds. Okay, so kita akan dapat jawapan induced EMF is equal to, okay, 2.5 times negative 3 exponent negative 3 volt. Okay, so this is the answer. And for the second part, determine the direction of the induced current in the loop. Okay, so in order to determine the direction of the induced current, so here I have a tree diagram. So the cross symbol here actually to show you that the direction of the magnetic field is into the page. Alright, and this white circle, okay, let's assume this as a coil. So alright, and alright, and I put this arrow to show you that the magnetic field, the direction of the magnetic field is into the page, and it is perpendicular to the coil. Alright, so yeah, so the arrow to show you that the direction of the magnetic field is into the page. Okay, so if the direction of the magnetic field is into the page, means that the front side of the coil should be north. Okay, so this should be north. Okay, and the back side of the coil should be south. Okay, sebab kita pun tahu kan, magnetic field dia arrow-nya mesti daripada north ke south. So kalau dia into the page, maknanya yang depan ini north, Okay, yang belakang ini adalah source. Okay, alright. Okay, so if you look at to the question, so the question state that determine the direction of the induced current. So when the loop is pulled out quickly from the magnetic field, okay, so what happened when this coil is pulled out from this magnetic field? So means that the magnetic field, okay, around the coil would be reduced. Okay, so the coil will try to oppose the change of the magnetic field, and the induced magnetic field, okay, will be try to increase. Okay, we will try to increase the magnetic field in the coil so that this side, okay, so kalau magnetic field ni bergerak ke sini, kalau kita tengok magnetic field ni keluar bergerak ke sini, asalnya tadi depan ni adalah north, okay, north pole, and this is south pole, okay, ataupun dia keluar bergerak ke sini. Alright, so when the coil is pulled out from the magnetic field, so what happened? The magnetic field around the coil would be decreased, right? So based on the Lenz's law, dia akan try to oppose the change, okay, the change of the reducing in magnetic field. So what happened? Okay, this side, okay, automatically this side dia akan jadi south, and belakang akan jadi north. Okay, kenapa macam tu? Sebab dia nak attract more magnetic field. Okay, so bila coil ni keluar daripada magnetic field ni, so dia akan kekurangan magnetic field. So bila bahagian depan jadi south, so that dia akan attract more magnetic field. Okay, dalam masa yang sama dia akan try to attract more magnetic field in order to maintain the amount of the magnetic field in the coil. Okay, so nak tentukan induced current, so in order to determine the direction of the induced current, macam mana? Okay, so kita ambil color lain. Okay, so letak ibu jari awak into the page, okay, ke arah belakang sebab north kat belakang. Okay, ibu jari mengarah ke north. Alright, so okay, this is right hand grip rule so ibu jari ke arah north, and then the other fingers awak tu dia akan curl, direction dia akan ke sini lah, which is clockwise direction. Okay, so dia macam ini. Okay, harap awak boleh imagine lah. Okay, so this is I. Saya tak I. That's mean the induced current. Okay, okay, so let's proceed to question 4C. Alright, so here we have two coaxial solenoids, P and Q, and they are 400 and 700 turns. So NP is 400 and Q is equal to 700 turns. Okay, so given that the current 3.5 ampere flows in coil P, so means that IP is equal to 3.5 ampere. So siapa yang ada current? Coil P lah. Okay, so the average flux of 300 microweber through each turn of coil P. So the flux of P is 300 micro, okay, Weber, and for Q, okay, is 90 times 10 power of negative 6 Weber. So based on the information given, so I will use this equation, M equal to the number of turns for Q times the average flux, okay, the average flux in Q, so the average flux in Q, okay, divide, okay, siapa yang ada current, so the current in P. Okay, so we substitute all the values, so 700, this one 90 microweber, okay, and the current that passed through coil P is 3.5 ampere. Okay, so the final answer, the mutual inductance of the two solenoids should be 0.018 Henry. Okay, so yang ni kena tengok betul-betul current pada siapa. Okay, so kalau current pada sini, kalau current dekat P, okay, so maknanya yang atasnya adalah the number of turns for Q and flux for average flux for Q juga. Okay, so kalau you masukkan ini P juga, salah lah, dia akan jadi salah. Okay, so finish question number 4. So let's continue with question number 5. So the question states that a voltage V represented by the equation V is equal to 15 sine 377t. Okay, So let's compare with the general equation. V is equal to, this one should be V naught, okay, the peak voltage sine omega t. Alright, so it's applied across a pure capacitor. So we want to talk about pure capacitor circuit. Maknanya ada capacitor je lah. Okay, ada C je. Okay, and given that the capacitance of the capacitor is equal to 250 microfarad. Okay, so one, determine the RMS voltage. So we want to determine the RMS voltage, right? But from the equation here, okay, kalau you tengok from the equation here, okay, we already know that this value 15 is actually V naught. Bukan VRMS, okay, dia adalah V naught, peak voltage, and it's equal to 15 volt. So, sekarang kalau nak cari VRMS, remember, okay, relationship between VRMS and V naught, okay, VRMS equal to V naught over Z2. Okay, formula kena ingat lah. Okay, dia dah bagi kat depan tapi tengok formula ni ada ke tak ada. Kalau tak ada kena ingat. So, 15 over Z2. Okay, so the answer is equal to 10.6 volt. Okay, ni awak check. So, 15 over Z2. Okay, and then A2, okay, calculate the frequency of the voltage. So this is very simple, right? Okay, so same goes to the previous part. So we can get value of omega from the equation here, where omega is equal to 377, okay, radian per second. Okay, remember equation of omega is equal to 2 pi f. Okay, therefore f is equal to omega over 2 pi, and 377 over 2 pi is equal to, okay, 377 over 2 pi is equal to 60 Hertz. Okay, 60 Hertz. Okay, so finish question A2. And then A3, calculate the capacitive reactance of the capacitor. Okay, so the question is really straightforward. Okay, we want to calculate what is XC. So, kita dah tahu kan frekuensi tadi. So, XC is equal to 1 over 2 pi FC. So, we can just substitute 2 pi. Frequency is 60 Hertz. And C is 250 micro. Okay. And it's equal to 10.6 ohm. Okay. 10.6 ohm. Okay. Last one. Calculate the RMS current flowing through the capacitor. Jadi untuk nombor 4 ni, soalan ni pun kita dah tahu this is pure capacitor. Okay, so like this one. So kita ada C. Alright, so we want to calculate IRMS. So from here we can use formula from VRMS. Tadi kita dah dapat where VRMS is equal to I RMS XC. Okay, chapter ni paling senang. So kalau salah, rugi So kita nak cari IRMS. So it's equal to VRMS over XC, where VRMS is 10.6, okay, and XC is equal to 10.6 ohm. Therefore, IRMS is equal to 1 ampere. Okay, so dah dapat jawapan. Okay, so finish 5A. Okay, so continue with 5B. Okay, questions 5B. So figure 8 shows the values of the RMS voltage across resistor, inductor, and capacitor. Okay, so this time we have RLC circuit. Okay, so determine the total voltage supplied, the phase angle between the total voltage with the current, and the power factor of the circuit. Okay, so macam mana kita nak buat ni? Okay, so kita tengok dululah. So based on the Phasor diagram given here, okay, so we have VL, VR, and VC. Okay, and always remember, okay, that current, okay, current I is in phase with VR. Okay, so current kena ada kat sini I. Okay, so now let's compare between VL and VC. Get here, so VL is 320. While VC is 130, means that VL is bigger than VC, therefore the phasor diagram now is like this. Okay, so we have VL minus VC, and this is VR, and we have I, and here, look at here, okay, oh sorry, so the resultant arrow here is, okay, VRMS, okay, and this is the phase angle. Okay, so the question give us VR, which is 140 volt. Okay, ni kita boleh kira lah VL minus VC, 320 minus 130. Okay, so dia nak suruh kira apa yang pertama? The total voltage supply. So the total voltage supply is actually VRMS. Okay, so kita nak kira VRMS. Okay, so if you look at this phasor diagram, you can see here we have a triangle. Actually, we have a triangle. Okay, triangle macam mana tu? Okay, ini saya dah pernah terang dah kat video set 1. Okay, kalau kita ada triangle macam ni. Sekejap So, ini adalah VR, which is 140 volt. And here is VL minus VC, okay, which is 320 minus 130. 320 minus 130, and it's equal to 190 volt. Alright, and here is a VRMS. Okay, so it's actually a hypotenuse. So in order to calculate VRMS, so it's equal to, okay, take the square root, VR squared plus VL minus VC squared. Boleh? Okay, so we can substitute all the values. So VR tadi berapa? 140 squared plus 190 squared. Okay, therefore VRMS is equal to 236 volt. Okay, awak check lah. Okay, ini jawapan yang saya ada. Okay, okay, so 5B2, the phase angle. Okay, so the phase angle, so I want to write my answer here. Okay, B2. Okay, so we want to calculate the phase angle. We still can refer to the phasor diagram here. Okay, look at here, we have the phasor diagram. Okay, so this is the phasor diagram, right? Okay, so we can write cos. Okay, guna cos boleh, nak guna sin pun boleh. Okay, so let's say we want to calculate by using cos phi pun boleh. Tak nak cos, nak guna tangent pun boleh, sin pun boleh. Okay, so let's say kita guna okay, cos phi is equal to, okay, VR over VRMS. So phi is equal to cos, okay, so VR is 140 over VRMS is 236. Okay, so therefore, cuba kira berapa dapat? Okay, 53.6. Okay, 53.6 degree. Okay, make sure you're calculated in degree mode so kita nak kira the angle. Okay, kalau dalam radian jawapan dia akan dapat salah. Boleh? Okay, so 3, calculate the power factor. Okay, power factor the circuit. Okay, power factor of the circuit. So remember, power factor is equal to, ni pun samalah, markah-markah free je ni. Okay, power factor is equal to cos phi, and it's equal to cos 53.6. Make sure your calculator in degree mode. Okay, so the answer is 0.59. Tak ada unit ya. Okay, so this is the answer. Okay, so now we have finished question number 5. Means that we have finished part 1 for set 2. So I hope I can still continue for the second part of set 2. Okay, doa-doakanlah. Okay, so saya harap semua pun masih bersemangat untuk bersedia bagi PSPM 2 tak lama lagi. Okay, so itu saja daripada saya. Jumpa lagi. Assalamualaikum dan selamat berusaha.